periodic matrix, and if your system in flocket system, so in that case your eigenpairs doesn't satisfy for fundamental matrix. Okay, so today we will explore about what is your flocket system, and what are the different lemmas, and then we prove our flocket theorem. So today we will only explore about the three lemmas, and try to prove that lemmas. Okay, so here uh, the definition is simple. Okay, so here a matrix, suppose A is a periodic matrix. If suppose this matrix be a periodic, so this is a periodic matrix with suppose period is T, that is greater than 0. So if our this matrix is periodic, this means this equals to AX for all X. Okay. So here your flocket system is we can write y prime that equals to AX y. Here this matrix AX, coefficient matrix AX, with a periodic over period T. Okay, so this system is your
हेलो सर सिस्टम का क्या लेना सर
uh, here the flocket system. This is okay. We can write here. Okay, so this is your flocket. Okay, so this is the flocket system. Okay, this is the scientist, mathematician basically. Okay, so this discover this system. Okay, so here if we take some example are okay. So yesterday we have already defined what is a periodic coefficient matrix. Okay, so here we take any sine or cosine coefficient of this matrix, and this sine and cosine are the periodic, or anyone. You can take any one form which are the periodic one. Okay, so here okay, so here we take a lemma, and that lemma is if your mx is a fundamental matrix, this is a fundamental matrix of equation 1, then this is also be the fundamental matrix. Okay, so if this is the fundamental matrix, then this mx plus t, this is also a fundamental matrix. Okay, this is a fundamental matrix. Okay, so the proof of this lemma is if you assume that say any matrix, say nx, and this is equals to m of x plus t. Okay, because this be the t be the periodic, so this means this t be the real one. So this is the function of only x. So we define this matrix mx plus t as suppose this is the and the matrix which is denoted by nx. Okay, so if we take this thing and here note that what is the differentiation of that matrix with respect to x, we can write here m prime x plus t. Okay, so this means this type of similar result we had already proved in previous classes. So here this m prime and this mx be the fundamental matrix of this system, this system. Then this mx also satisfies this system, locate system. Okay, so this means this m prime, this m satisfies this thing. So m prime equals to this a of x plus t, and here this becomes m prime equals to mx, because this if m be the fundamental matrix of this system, then this also satisfies this fundamental matrix form like this. Okay, so you know that this result already we had proved in previous classes. Okay, so this means this m is the fundamental matrix of this system, so m prime equals to am. From this relation we can write this a of this, and m is x plus t. Okay, because this is not x here, x plus t, so this is of x plus t. Okay, and since this is your uh, periodic coefficient matrix, so this means you can write down here this n prime x is equals to this a of x plus t. This is simply ax due to periodicity of this matrix, and here this becomes m x plus t. Okay, and what is the value of m x plus t? That equals to nx. So this implies we can write here this n prime x, this equals to ax nx. Okay, so this means you can also see that if this n is also satisfies of this type of relation. This is n prime equals to an, and here m be the fundamental matrix, and this satisfies this system. Here also n be the also a matrix which satisfies this matrix equation. This means this is also the solution of that. Okay, so here you can also check that this is a non-singular one. Okay, so due to we check that, this means also the determinant of this matrix is non-zero. This means this is the determinant of your if we take this nx is mx plus t, so this is the determinant of that. And due to this is a fundamental matrix, this is the fundamental matrix, so this is a non-singular, so that's why this m with the fundamental matrix, this is equals to not equals to 0 for all x belongs to that domain. So you can write here, because this is due to this mx is fundamental matrix. Okay, so that's why this is non-zero. So here you can conclude that this matrix ns that satisfies this matrix equation and also be the non-singular. So this is fundamental matrix. So this is your fundamental matrix of system or equation first. Okay, so this means if any mx be the fundamental matrix of that, and that quotient is matrix is periodic over T, so this mx be the fundamental matrix, and also mx plus T is also the fundamental matrix of that system. Okay, so this is the simple result. Okay, and similarly another there is another result. So if we denote this is a lemma 1, suppose that this is lemma 2. Okay, so this is lemma 2. Okay, so the next lemma says that if this mx is a fundamental matrix of equation 1, so then there exists a non-singular constant matrix, non-singular constant matrix, that is C, with mx plus t, that equals to mx with multiplied by constant matrix C. Okay. So this is also a result if this is the fundamental matrix of your Flockit system, and here this quotient matrix with a periodic over periodicity T, then this mx plus T is equals to mx into that constant matrix C. Okay, so this result we can prove by the okay. So here we take this is any nx be the solution, and here we can prove that that solution be the unique solution. Okay, so in next page we try to prove this result. In next page,
सर यहाँ पे सर ग्रेड एग्जिस्टेंट नॉन के बाद क्या लिखेंगे सर?
कहाँ पे ये इस लाइन में नॉन सिंगुलर,
सर सेकंड में
नॉन सिंगुलर, दिस इज नॉन, हम इसे इरेज कर देते हैं. नॉन सिंगुलर. ओके, तो चूंकि ये चौक और ब्लैक बोर्ड होते तो क्लियर होता है, थोड़ा सा यहाँ मुश्किल है लिखना, बट आप कहीं कंफ्यूजन हो तो आप हमसे पूछ सकते हो, कोई दिक्कत है. सो इन नेक्स्ट पेज proof. So here we assume that, let us start with this assumption, our this mx is a fundamental matrix. This is a fundamental matrix of a Flockit system, or we can write this is question number 1. Okay, so by lemma 1, so by previous lemma, so this lemma 1, this lemma, you know that your nx, this equals to, if m be the fundamental matrix of this Flockit system, so you know that mx plus t, that is denoted by nx, this is also be the fundamental matrix of your Flockit form. So this is a fundamental matrix of system 1. Okay, so this is question first, and here if we define, if we define our, because this is your fundamental matrix, so this is non-singular, so this means, and mx be the fundamental matrix, this means this is also non-singular, this means inverse of this mx is also exist. So if it take this cx, this equals to m inverse and nx, if we take this will be the any matrix that calling by C. Okay, and here due to m be the fundamental matrix, this is a non-singular, so inverse exists, and here nx be also fundamental matrix. So if you multiply both matrices which are non-singular, then this is denoted by ender matrix C. Okay, this is also non-singular. Okay, oh, this means this is cx equals to this thing. Okay, so here for all x. ओके, तो ये सिंगुलर हो भी सकती है, नहीं भी सकती, क्योंकि इससे मतलब नहीं है, क्योंकि आप जानते हो कि दो नॉन सिंगुलर मैट्रिक्स के मल्टीप्लिकेशन सिंगुलर भी होते हैं, तो उससे कोई ओके नहीं ऐसा नहीं. ओके, तो दिस मींस m इनवर्स x इक्वल्स टू nx. ठीक है, सो हियर देन okay, so this here we can write directly what is nx here. So we are interested to find nx equals to, if we pre-multiplication of m to both sides, so this becomes nx cx. Okay, so if we define, this is my question number 2. Okay, so if we fix our this x को अगर हम fix कर लें, suppose any real constant, which is x naught, and here the what is the value of c at x naught. So if we define by this is a constant matrix because this is a function of x, and if we this x is fixed real, so this is a constant matrix. So this c0 this equals to this is c at x equals to 0 if we define that x naught. Okay, so here, what is the value of this thing? So here, if we write this n0 at any x, if this equals to mx, and here we put here this is for fixed c, so this is c0. So here we can write this is c0, and this is not n. This is if you deny this is n naught. Okay, not x naught, because if x is fixed for all, so this is a constant, this is constant, and this is one constant. Here we only take this matrix is constant for any fixed x naught. So this is the value of this x naught, and here we denote this is n naught. Okay, n0. Okay, so where this thing, this condition hold when c naught is any non-singular constant matrix, because this is a constant matrix. Okay, so this is a constant matrix. Okay, so this implies here this is the fundamental matrix and this is the non-singular matrix. The product of these two non-singular matrices is also the non-singular. So this means this implies n naught x is non-singular. So here, if this is non-singular, so we have what is the value of this? If we differentiate this with respect to x, this equals to here this m of x c naught differentiation of this, and here this c naught be the constant matrix. This is simply this equals to m prime x and here c naught, because this is the constant matrix. Okay, so here m prime and m prime, it is a fundamental matrix. This satisfies your matrix equation. So this becomes a of mx or ax of mx, and this is c naught. Okay, so due to this, because m prime is equals to am, this satisfies your original system of equation. Okay, and this is m with the fundamental matrix, so this satisfies your matrix equation. Okay, so here you can write n naught prime x, this equals to this becomes a of m naught x mx this, and here this term is, look here, this term mx c naught, this becomes n naught. This term is your n naught x. Okay, so here this n naught prime is equals to a and n naught x. Okay, so therefore here you see that this n naught prime is also satisfies this matrix equation. This means this equals to a of n naught. This means this is also the fundamental matrix of this system. Okay, so therefore we can write here this n naught x is fundamental matrix. Okay, this is also fundamental matrix, and here this is due to this is due to because this n naught x that equals to a of mx. Okay, so that's why we write here this term here. Okay, so ये value हमने यहाँ पे इसलिए रख ली. Okay, so suppose this is your equation number suppose 3. Okay, so we have two fundamental matrices, two fundamental solutions of our Floquet system. That is one, namely first one we have assumed that is annex with also fundamental system of equation 1, and here this n naught be the also fundamental solution of equation 1. So that are first one is nx and second one is n naught x. Okay, so these are two the fundamental solutions of same our Floquet system. Okay, so here what is the n naught x? So n naught x means here the value of n at fixed x naught, and that if that equals to n naught x naught. Okay, so if we for fixed x naught, this value is this thing. Okay, so here by uniqueness theorem, here by uniqueness theorem, you know that these two solutions are same. So we can uniqueness of solutions. We can write here uniqueness of solutions. The matrices in equation 2 and equation 3, this must be equal. Okay, so this means that if these two are same, this means here nx equals to mx cx, and here your n0, this n0 x equals to, okay. So this means this is question number 3. Okay, so this is the question number 3. Okay, so okay. This thing. Okay, so here I don't need to redefine here. Okay, so here this nx equals to this thing and n not x equals to this thing. So if we compare these two, so this means this result and this, these are the two are same. This solution are same. So this equals to mx, and this means cx equals to c naught. So here we get this c0. This equals to your cx. Okay, c of x. So for all x. So therefore, your c is because for all x, this matrix becomes a C0, and C0 with your non-singular constant matrix. Therefore, your this matrix C is a constant non-singular matrix. So this is constant matrix. Okay. So therefore, your solution is, what is your solution? Solution is this becomes mx plus t, and that solution is equals to nx, and that nx equals to mx into cx, and that cx be the constant matrix. So this means you can write here your nx is basically mx plus t, and your nx is mx, and what is your c be the constant matrix. So this becomes c. So this is the proof of your lemma. Okay, so here the another lemma, which is a important one and also the lengthy, because the proof of this theorem is I think 2 or 3 pages. So in next page, okay, so there is another theorem lemma, that is 1 2, this is 3. Okay, this is 3, third lemma. Okay, so if you see is n cross n non-singular matrix. Okay, if C is n cross n non-singular matrix, then there exists n cross n real or complex matrix. Suppose that is B, such that this exponential matrix that equals to constant C. Okay, so this is the lemma. If C be any non-singular matrix, then there exists a non n cross n complex matrix, that is say if B, such that exponential of this equals to the constant c. Okay, so this is your lemma, and this result is used in your Floquet theorem. Okay, so proof of this theorem is uh, also lengthy and some difficulties in there. Okay, so start with okay, so we have 30 minutes, so we try to prove this theorem in 30 minutes. Okay, okay. तो मुश्किल है, लेकिन फिर भी करते हैं, कोशिश करते हैं कि 30 मिनट में ये हो जाए. Okay, so right, C is right, C basically this is non-singular matrix. So any non-singular matrix we can write in basically Jordan form. So if we write C in the Jordan form, or Jordan, if we take n cross n, so we can reduce this in the Jordan block. Okay, so if we write this in Jordan canonical form, write this in Jordan canonical form like this P inverse CP. Okay, and you know that here P be the non-singular matrix, P is non-singular matrix, and that matrix is obtained by the eigen pairs. Okay, eigenvectors. Okay, so this matrix consisting of eigenvectors of your given matrix, that is C. Okay, this C. Okay, so if this exponential matrix that equals to C, if this condition is true, okay, so if this condition is true, then what is the value of this e to the power this P inverse BP? So this equals to, you can write this P inverse exponential of B and P. Okay, and that is equals to P inverse. And if this is true, so we can write here this is C and this is P. Okay, and that equals to your Jordan form J. Okay, so if this condition is true, so this becomes this is your J. Okay, so therefore we can write here. Therefore, it is sufficient. It is sufficient to prove that. It is sufficient to prove that the statement for C, the statement for this C matrix having the form of a Jordan block. Okay. So if we consider if your Jordan block, okay, this means your matrix and there are certain Jordan blocks is there. Okay, so if we assume that our lambda j, that is for lambda j when j is suppose this j can be the eigenvalues, अगर इसकी n values हैं तो आपकी नॉन सिंगुलर है, दिस मीन्स कोई भी आइगन वैल्यूज आपकी जीरो नहीं होंगी, और आइगन वैल्यूज आपके डिस्टिंक्ट हो सकती है, कुछ आपकी इक्वल भी हो सकती है. तो उन केस में हम j को जो है दैट j इक्वल्स टू 1 to suppose r, these are eigen values. If of course this r is if all are distinct, so this equals to n, and if there are repeated roots, in that case this r is of course less than n. So here this j is 1 to r, and here r is less than n. Okay, so here we can write here this is 1 to r, and here r is less than r equals to n. Okay, so here we write in this form. Okay, so this denote is this lambda j. This denote the eigenvalues of your matrix C, and since the C is non-singular, so your any lambda j is not equals to 0 for all j that equals to 1 to R. Okay, because this is n cross n matrix, so there are n eigenvalues. Okay, so that means non-singular. So any eigenvalues are non-zero. Okay, and if you suppose that this C, this matrix C, this equals to diagonal of C1, C2 up to there are lambda 1, lambda 2 up to lambda R. So if this R may or may not be equals to n, so this means this is equals to n or less than r. So this means this diagonal element is up to your C R. Okay. So where what is your Cj of the form, and here our this is the block mat Jordan form, and this Cj is of the form, and that Cj is of the form. Cj is defined like this lambda j, diagonal entries are lambda j up to lambda j, and here this is 1 1 and this is who's 1. So this is your Jordan block, and here j is 1 to up to r. Okay, so here let the size of this any Cj, the size of this Jordan block, any this size of Jordan block, if this size is suppose if we take the size is Sj cross Sj. Okay, so this is the size. So in next page, we write what is the size of this Cj. So in next page, so let this Sj cross Sj be the size of your matrix Cj. So we have what is the value of Cj here. So Cj equals to your that is diagonal entries are lambda j with identity matrix, and the size of that identity matrix is also this Sj cross Sj, and plus the nilpotent matrix of Nj. Okay, so here this j is 1 to R. So this with the size this Sj cross Sj identity matrix Ij. Okay, so this Ij matrix has this size, and the Sj cross Sj matrix that are your nilpotent matrix, and that nilpotent matrix Nj. So both has same size because Cj of order Sj cross Sj. So this is the identity matrix of same order and nilpotent matrix. And what is this your nilpotent matrix? Here the diagonal entries are 0. Here the diagonal entries are 0, and okay, so 0, and here this term is 1. Okay, so this is your the nilpotent matrix. So this becomes this is 1 here, and this is 0. So here we can write in this form. So here, okay, so this is your nilpotent matrix with all diagonal entries are 0. Okay, so this is your Nj having the property and this property is this of order Sj that matrix equals to 0. Okay, this property is your matrix Nj of order Sj, or this equals to this null matrix. Okay, so here we have also this summation of that if we adding our all order, that all order, if we adding that equals to your main order of the matrix, that is n. Okay, so if this are any general Sj, okay, so if you adding all the Jordan block of this matrix order, okay, so you suppose if this is of order and suppose this is another general block and suppose this is the and the suppose, so if you adding these plus this equals to your n cross n main matrix. Okay, so here so the standard form, so
सर
the
वो जो
uh,
एनजे सर एनजे लीक इक्वल टू जीरो सर वो क्या है सर?
this nj sj equals to 0
यस
because ये nilpotent मैट्रिक्स है. nilpotent मैट्रिक्स ऑफ ऑर्डर होगी ना कुछ nilpotent मैट्रिक्स आप जानते हो ना कि वो कैसे होगी. nilpotent मैट्रिक्स की कुछ ऑर्डर होती है, जैसे कि ए आपकी nilpotent मैट्रिक्स होगी ऑफ kth ऑर्डर इफ a to the power k equals to null matrix. You know that definition of nilpotent matrix. ओके, तो इस तरह की मैट्रिक्स जिसके कि आपके डायगोनल एंट्री 0 हो, अपर इज 1 हो, ये आपकी किस ऑर्डर में 0 हो जाती है, जो इसकी ऑर्डर होती है. तो इसकी ऑर्डर क्या है, एस जे. एनजे की ऑर्डर क्या है, एस जे. तो एस जे कुछ ना कुछ एक रियल फिक्स नंबर होगा ना, ऑर्डर है सपोज 3 4 5 कुछ इसका नंबर होगा. तो एनजे टू द पावर दैट इक्वल्स टू नल मैट्रिक्स 0. क्लियर. एनजे किस ऑर्डर की है, दिस मैट्रिक्स इज ऑफ ऑर्डर एस जे क्रॉस एस जे. तो इसकी इस ऑर्डर की वैल्यू क्या हो जाएगी आपकी, 0 हो जाएगी. ठीक है. दिस इज द प्रॉपर्टी ऑफ मैट्रिक्स. ओके, this is property of matrix. If the all diagonal entries are 0, upper triangular matrix, if any upper triangular matrix of 0 diagonal element, that is nilpotent matrix of order, that is the order of that matrix. This is a result basically in matrix theory. Okay, from that theory you can write this nj of order sj. This is the order of nilpotent matrix that equals to 0. This means if we multiply nj in sj times, that equals to 0. Clear. So we constructed a matrix that is C of size, and your matrix C of size, that size is n cross n. Okay, so here we have to construct our matrix C of order n cross n, and that satisfies that relation. So if we can show that any this Cj, this equals to, basically we have to prove that C equals to this constant matrix equals to exponential of b. Okay, so we have to prove this thing. So here we try, this C is different in Jordan form. So if we try to form, if any Cj, if we can show that for each Cj, if for each Cj that equals to exponential of bj, then we can show that this is C equals to E of B. Okay, so this is our thing or objective to we can prove this thing. Okay, so if we write here the same thing. If we can show that, for each Cj there exists any matrix bj such that your Cj equals to exponential, sorry, Cj exponential of bj, or you can write here this bj, or you can write here this C. This implies that if you can able to prove that if our each Cj is equals to this thing, so you conclude that the C is exponential of b. Okay, so this implies that thing. Okay, so since what is the value of Cj here? So since we have to prove this thing, so Cj that equals to, what is the Cj? Cj is here. So Cj, if we take this real lambda j, if we take lambda j is common. This is your identity matrix, and plus this is nilpotent matrix over this real lambda j. So if we take lambda j is common, okay, and here what is your j? J is varying from 1 to any real r, okay, and if you're using, okay, so if we're using the expansion of well-known expansion, this is log 1 plus x. What is expansion of this? So this is a summation minus 1 to the power k plus 1 if we varying from k equals to 1 to infinity. So this is k equals to 1 to infinity minus this by k, and this equals to x to the power k, where mod x is less than 1. Okay, so this is the expansion of what is log 1 plus x. Okay, so here we can apply this formula. We can apply this formula in this CJ form. Okay, so in next page, what is the value of bj? So bj is equals to, you can write here, bj equals to log of cj. What is the value of bj? Bj equals to log of cj, and cj equals to this thing. So here in next page we write here, so what is the bj? That bj is log of cj, and that equals to log, what is cj? Cj is basically lambda j ij plus nilpotent matrix, this thing. This is the log of that thing. Here, if we log of this, means this into this, so log m plus log n. So here, this is the matrix form. So here, log of lambda j, so lambda j be the real one. So this means you can write here, if we this multiplied into matrix, because this left hand side is the matrix form. So here you can write here, if you multiply this identity matrix with your log of lambda j. This is the first term, and plus this is second one is log. Second term is this thing, ij identity matrix plus nj over lambda j. Okay, so this implies you can write bj, this equals to this is identity matrix ij log, so ij log lambda j, and plus log of this means identity plus this thing, and we expand this by previous formula. So this equals to summation k equals to 1 to infinity minus 1 to the power k plus 1 over k, and here this x is nj over lambda j, and this power k. Okay, so this is the expansion of your log 1 plus x. Okay, and since you know that your nj be the important matrix of order sj, so this means this power sj that equals to 0. So we actually have here this k equals to 1 to infinity, but here when k be the real one, k 1 2 3 4 and so on up to the infinity, and here this is nj to the power k. Okay, so if this 1 to k varies from 1 to sj, then this is of sj. Okay, so sj be the nilpotent matrix, so this term becomes 0. So if we expanding this term, so 1 2 3 4 up to sj minus 1, sj plus 1 and so on. So when we go through, जब k equals to sj होगा, so this is the nilpotent matrix, so this becomes 0. Okay, so this means the उसके आगे k plus 1 sj plus 1 sj plus 2 जो भी आप लेते जाओगे सभी की सभी 0 होंगे, because this 0 into nj square, that all are 0 due to this nilpotent matrix. So this means our this bj, जो हमारा bj होगा, that bj which is in fact log of cj, this equals to first term is ij log lambda j, this thing, and this summation is only from 1 to sj माइनस वन, बिकॉज एस जे हमारा जीरो हो जाएगा, तो बस हमारे वहीं तक आप जाओगे जो हमारे नॉन जीरो टर्म है, दैट इज के प्लस वन over k, and this is of njk and jk k. So this is, and here k is only to sj minus 1 term. Okay, so this means you can write here ij log this lambda j plus, if we define this term as another matrix, say mj, and here what is j is varies from 1 to r. Okay, so this, suppose this is your equation number star. Okay, and here what is summation k is 1 to sj minus 1 to the power k plus 1 over k nj to the power k and lambda j to the power k. So this matrix is, if you donate, this is matrix is m. If we're solving this matrix, and that is this mj, we can write here this is your bj, and that equals to log of that. So this is a form of that. And here if we any confusion here, so you can write here since what is nj is nilpotent, so this n to the power k over lambda k, that equals to 0 for k and so on. So k and
लास्ट टर्म में क्या लिखना है?
क्या क्या बताएं बताएं लास्ट
लास्ट में समेशन में सर जो लिखा है,
हेलो
समेशन के बिलोंग्स टू
लास्ट लाइन ये
सर
आवाज नहीं आ रही क्लियर, क्या क्या
K is equal to
फिर
1
से फिर
ये सर के बिलोंग्स टू वन या के
minus
S1
1
SJ
K equal to 1
SJ minus 1 SJ minus 1, this is k plus 1
K is
k equals to 1 k equals to 1 k equals to 1 1 है, this is 1 k equals to 1 1 to sj minus 1, इसी को लिखा है, इसी मैट्रिक्स को लिखा है, this is your this matrix is in fact mj. क्लियर, ठीक है, चलिए तो ओके, तो इन नेक्स्ट पेज सो ओके, तो यहाँ पे हम एक लाइन और लिख लें, वी नीड to verify that this Cj that equals to exponential of log C. Verify that because our main objective is basically we have to prove that for each Cj that equals to exponential of Bj. Okay, or you can write this is log of Cj that equals to basically you can prove that this becomes what is the value of this Cj exponential of log Cj. Okay, so here if this equals to your Bj, okay, so this becomes exponential Cj equals to exponential of that Bj. Okay, so here we need to verify this Cj equals to exponential of log Cj in order to get basically Cj equals to e to the power Bj. Basically our objective is this thing. Okay, our objective is Cj is this Cj is equals to exponential of this thing. Okay, so we can write here, so we can write this expression means व्हाट इज सीजे? सीजे को हम लिख सकते हैं क्या चीज? एक्सपोनेंशियल एंड लॉग सीजे, this equals to, we have to find this value, we have to find this value exponential of log cj, हमें ये वैल्यू हमें फाइंड करनी है। ओके, तो हम नेक्स्ट पेज पे चलते हैं, यहाँ स्पेस की प्रॉब्लम है। ओके, सो इन नेक्स्ट पेज ओके, सो exponential of log cj, this equals to exponential of, what is the value of log cj? So log cj is already, you can find ij log lambda j plus this mj from previous page. Okay, so this is your exponential of this is exponential, so that's why okay, so here mj, so this implies exponential of log cj, this equals to you can write this is exponential of this into this, तो इसको आप लिख सकते हो ना, exponential of this term, this equals to exponential of ij log lambda j into exponential of mj, because this plus sign. Okay, so this plus this. Okay, so here due to identity matrix, so this becomes identity exponential of log this equals to lambda j into identity matrix. This means the diagonal term is lambda j, diagonal term is lambda j, the first term, into exponential of your matrix mj. Okay, so the matrix, this mj is the sum of the nilpotent matrix, so that's why this is also a nilpotent, this is nilpotent, और आप चाहे तो लिख सकते हैं, because since every upper triangular matrix with zeros on the diagonal is nilpotent. Okay, so hence we can write, we can use the expression, this exponential of mj, this exponential, this is equals to k equals to 0 to so this means this is not k equals to 0 to infinity for exponential, that is sj minus 1. Okay, so we will compute exponential mj for the case if we take for example mj is suppose 4 cross 4 matrix, so in that case what is the value of exponential mj? So here this exponential mj, this equals to k equals to 0 to sj minus 1, this is 1 upon factorial k mj power k, this is j, okay, so this equals to basically, if we try to find, this equals to diagonal entries are 1, okay, diagonal entries are 1, others are 0, so here this is 0 0 0 0 and so on, and then second term is, this is diagonal entries are 0 0 0 0, and here 1 by lambda j, 1 by lambda j, and this 1 by lambda j. The second entry is minus 1 by 2 -1/2 lambda j square -1/2 lambda j square. Okay, 1/3 lambda j cube. Okay, तो ओके तो मेरे ख्याल से 11 बज गए हैं। ये चीज अभी आपको शायद समझ में नहीं आएगी, मैं इसको एक्सपेंशन करके लिखना है, तो यहाँ से हम कल स्टार्ट करेंगे। ओके, तो आप यहीं तक ही चलें, यहाँ से हम नेक्स्ट कल हम बताएंगे। ठीक है, तो टाइम भी हो गए हैं। ये चीजें हम कैसे लिख रहे हैं, तो हम जल्दबाजी में लिखते हैं, आपको समझ में ना आए कि कैसे ये आ रही है, तो हमें इसको सॉल्व करना है। सॉल्व करके हम लिखेंगे और हम एक 4 का स्कोर के लिए हम चेक करेंगे, फिर इन जनरल n क्रॉस n के लिए क्या होगा। तो ठीक है, प्रूफ नहीं हो पाया आज, हमें मुश्किल लग ही रहा था थोड़ा लेने में। ओके, कोई बात नहीं, तो यहीं तक करें, यहाँ तक आप समझ लिया, यहीं तक करें। कल हम इसके आगे चलेंगे। ठीक है, तो
थैंक यू सर।
आप कल ही करिए, क्योंकि 11 बजे 2 मिनट
Thank you.
है, 11 बजे 2 है, तो आप चलें, कल हम यहाँ से आगे स्टार्ट करेंगे। ओके, ठीक
Thank you, sir.
ठीक,
Thank you, sir.
थैंक यू सर।